Okay, it seems like there are four people here. So what I wanted to do is I wanted to take one of the simplest problems and work it. You turn. So we're going to work this two ways, the standard way and then the what I like to call the quick way. Um, of course, you've got a tension here, which I'm going to call that TAC. You're going to have a tension here, which I'll call that TAD, and a tension this direction, which I'll call that TAB. It's all two-dimensional, so in fact, all I have to do is sum of the forces in the x equals 0 and sum the forces in the y equals 0. However, I don't have these forces laid out in x and y, so I'm going to start with the simplest one. And if I take that box and realize it's 550 pounds, it's pretty apparent that that's going to be 550 right there. Now, in the book, what he'll do is split it apart. In other words, he'll do something like this. Oops, wait a minute. He'll go out here, take this, move it over here somewhere. Okay. And then he'll say this tension has to offset that, and because of that, that makes the tension, okay, if you went in and did it, sum of the forces equals 0, and the y, 550. If we've done that, that's a positive. Minus TAD tells you that TAD is equal to 550 there. We're just going to do this by observation. So what I'll do is go ahead and here erase all that and just recognize that. Then the next key is to actually turn around and get these as vectors. So if I look at this, there is 4/5 of this. I'm going to slide this over because I'm working on TAC. So I'm going to say the magnitude, turns out it's 4/5 of the magnitude of the TAC, 4/5 in the x direction, plus 3/5 of the magnitude of the tension in the z direction. The y direction. So that being the case, I'm just going to hold that thought for a moment, not going to think too much about it. Then I'm going to basically work over here on this one. The TAB vector is going to be the magnitude of the tension in AB. I could probably come up with a better symbolization, but now turns out I have a triangle here. It can be broken broken into components, and it just so happens it's cosine of 30 in the I, but it is pointing to the left. Now, it is pointing directly to the sky, and the other one, sky being the positive y direction, and that's the sine of 30j. Now, so I've got these two tensions in a vector form. These are fairly simplistic. There is a possibility it could be much more complicated than this, but one is obviously going to the right, has a 3, 4, 5 triangle. The other one has a 30 degrees. The key here is this could be represented as a vector, and so technically, in other words, the equation here is the same as the equation here, except over here it's a little bit more general. And the reason I say that will become apparent in a minute. So if I want to look at the vector TAD, it's just minus 550j. There isn't an x component pulling it to the right or anything. It's just pulling it straight down. Now, before I ever start here, I should have done this. I should have said this is going to be positive to the right, this is going to be positive up. I didn't. I just put them in as the I and j components. Now, if I look at this equation now, this equation is pretty simple. The sum of the forces, all of them together. Now, if I do that, that should be a vector of all zeros. But I'm just going to keep it as a 0. And essentially what I've got is TAC, the vector, plus. So I got this one, I got that one, and I got that one. And that's it. TAB, and then TAD. That's it. Just so happens I can look out here and get the x component here, the x component here. There isn't a y there. I mean an x on that last one. Get the y components there. And, sorry, the y component here. So in fact, if I want to list this, okay, so I'm going to start putting a arrow across the 0 to indicate that it's a vector. And we can basically look at that in a minute. So what I'm going to do is I'm going to grab the yellow ones and then the green ones. 4/5 TAC, the magnitude of TAC, minus TAB, cosine of 30, that's I. And now I'll get the green ones. Minus 550 plus 3/5 times the magnitude of TAC plus the magnitude of TAB times the sine of 30, and that's the J. Now, to find out is you have these two components, the x component and the y component. So technically, if I were to do this the right way, I would say 0i plus 0j. So that is the vector. The reason I put a vector symbol over it for the time being is to make it generic. So in other words, this could be 0i plus 0j plus 0k. But in our case, we only have 2 dimensions, so we don't even have this. This covers everything. This is specific to our case. So now I have 2 equations. Now I can go and say this, and then say that. So if I start with the green equation here, what do I get from the green equation? Everything that has green in there, 0 is equal to minus 550 plus 3/5 of TAC plus TAB times the sine of 30. And that's the equation sitting there. That's it. If I want to get the yellow equation above, basically I have 0 is equal to 4/5 of TAC, the magnitude, minus TAB cosine 30, and that's the 2 equations I have. At this point, you could stare at it a minute and possibly drop it into a set of equations that would be a 2 by 2 Okay, so I'm going to list TAC, the magnitude first, TAB, the magnitude in the second one. Now, I'm going to go ahead and list the yellow equation here, the green equation here. I'll list the here, this was kind of implied, so I'm going to make it TAC and then TAB, and these go with that, and these go with this. I'm just putting the headers over them, and then this will be the rows, these will be the columns. So the first thing I see is this 550 goes to the other side, and it's in the green equation. The 0 is out there by itself. So then the coefficients of TAC in the first equation is 3/5. The coefficient of TAB in the green equation is sine of 30. Now I go to the yellow equation and look at the coefficients of the TAC there, move over to the coefficients of the TAB in the yellow equation. Okay, so now I'm sitting here staring at this and realizing I've got a matrix, and I did not start octave. I should have. Give it a minute. Okay. So I stare at this. Hang on, let me move. I'll get as much of the screen as I can. I'll call the matrix on the left K. And what I'm going to do is 3/5 then sine degree of 30. Next row is going to be 4/5 minus cosine degree of 30. There's my matrix. 0.6, 0.5, 0.6, 0.5, 0.8 minus 8.66. That's TAC, TAB equals to 550 and 0. I should be able to now take the inverse of my matrix K, multiply it times another matrix, which will have 550 in the top, nothing in the bottom, and I get my answers. 470, 0.86, TAB. These should actually have the magnitudes here. And that would be 434.96. Now, I could try to find the answers in the back of the book, but I doubt that it would be a fruitful task here. So I only have 34 pages. I broke this into sections. If I have my, it is possible. I doubt it. This is F 3.1. But we can attempt it. Maybe. I don't know. Let's see. It'd be 1. Would this be it? Nope. 3.1. Okay. Looks like I'm wrong. Now let's see what I did wrong here. Whoa. Major error here. Let's see if I can find it. Okay, so I've got a cosine listed here in the X. I think somehow that got translated into the Y. Let's see if I can see where it got translated into the Y. Okay, so here's my yellow. This is my X. This is my X. 4. This is my X. Got translated into here. And TAC and TAC are fine. But the cosine and the sine, let me go back and see. Okay, so we'll go ahead and give in that, that we're incorrect there. Let's see if I can find where I messed up. TAB, going to the left, going north. Pull the eyes out. I still have it. Still have that. This TAB is associated with the eye. Ooh. Oh, well. Okay, I'm trying to stare at it. Well, let's do this. I will now move that all to the right, and I'll work it the second way. Or, better yet, I'll take the picture, we will copy it, move it to the right, we'll work it a second way, and compare the two. Oops. I'm not getting any response now. Okay. When this happens, I've got to just drop that out. I'll reload it. Okay. It all looks different. Okay. So I'm going to try a secondary approach. I'm going to hold and say I made an error. Now what I'm going to do is I'm going to do something totally different. I'm going to come up with the base vector in each direction. And say, I'll say unit, let's call this unit 1 vector. I could call it AC, so maybe I'll do that, is equal to, and it looks like I'll be 4/5 of I plus 3/5 of J. I'll take the unit vector over here, AB, and this vector moves to the left, cosine of 30, I, and it moves north, sine of 30, J. This one, AD, just moves minus 1, J. Now, what I'm going to do, since I know this one's going to have my load of 550, I'm going to look at these two. And what I'm going to do, I'm going to immediately write my equation down. And what I need to be able to do is slip in I'll start with UAC here. I'm going to list them as 4/5 and 3/5. I'm going to list UAB as minus cosine 30, sine of 30, and I could do this as well. UAD, nothing, and minus 1. Now, what I have is a 2 by 3. I don't have a 2 by 2. But if I were to list these, it would say the tension in line AC, the index associated with this one, tension in line AB, and the tension in line AD. Now, I already know that one. That one I can just replace with 550. Now, what I can do, I could, since this is a matrix which could now be broken apart with this one times these, that's what I'm going to do. Let's say 4/5, 3/5 minus cosine 30 sine of 30, and I'm just going to write TAC and TAB, but this time, okay, so I'm taking 550 times 0, 0. Now, I didn't do this, but I should have. 0, and then 550 equals to 0 and 0. This came from this number times that column. Now, if I go in here and take a look at what I did wrong, I'm just going to go to MATLAB first, or to Octave first. Then try to get these so they can go back and forth. What did I do? Okay, so what I did, okay, so if I look at my equation, it appears to me that I flipped. It won't get any smaller than that. Appears to me that I had, let's go ahead and do this. Let's say, now we're going to call this matrix K1, and it's going to be 4/5 minus cosine degree of 30, and then 3/5 sine degree of 30, and it looks like I simply flipped the things. Then I moved the 550 to the right hand side and inverse K1 times what appears to me to be 0 and 550. And I think I did it right. I think what I ended up doing, I ended up, if you notice right here, I ended up with this 500 instead of 550. So if I use this and go back and put 550, I would have got the right answer. So now let's take a look. So it's 517 and 478. And okay, so 478 and that. Now, let's go back here and compare what we ended up with in the two equations. Okay, so what I'll do is I will move these a little bit to the left so I can zoom in. Now, I did something kind of goofy that I usually don't do over here. I did something goofy over here. If you notice, the yellow is the X, and I put the X down here and the Y right here. So I simply swap the two equations. And so this is essentially what you see here, is that I swapped the two equations. Generally, the way I work when I'm working over here in this particular method is and it turns out that this method works correct the entire time, but I establish like a certain protocol. protocol is I generally try to put the x equation here and the y equation here. The base vector, there generally will be 3 of them. And one of them, in this particular case, the last one, was known. In other words, here I had some tension 1, tension 2, and a number. Turns out what you do is you list the base vectors vertically, not the base vectors, the unit vectors. The unit vectors, I keep calling them base vectors, but list the unit vectors vertically. In this particular case, I knew this number, so I can multiply it out, giving me back a 2 by 2 with a right-hand side that has something besides 0 on it. So, in fact, that's a procedure that works every single time. Let me find another problem real quick and I can work it that way. Okay, wait. Okay, let's see. Okay, here's where we were. Let's just find something else that might happen to be similar, yet maybe a little different. I'm looking for I don't want to see any springs, I just want to see. Let's just look at this one. Okay, so this is 29 and 30. So I'm going to work off of 29. Okay, it should have given me a... there we go. I'm going to work off 29, so I'm going to grab the picture. And drop the picture, then go back and get the text. Oops. Okay, so there's my picture, there's my text. Here's the issue here. I have 2 rings, this one and this one. Each one has to be done separately. So what I'm going to do, I'm going to go in, I'm going to take all my base vectors here. I'll call this UD. Since it's located at D, I'm just going to say what direction they're going. UF and UC. Now, I'm going to go ahead and list the X and the Y components. This is maybe a little unorthodox, but UC, UE, and UF. Now, I can do the UF really simple. In other words, UF is equal to 0I minus 1J. That's all that vector is. Now, if I list the UE, I get a direction to the right, cosine 30, direction going up, sine of 30. UC goes directly to the left and has nothing to the right. He tells me, okay, so tension towards C, which I guess, hang on. Now wait a minute. UF was correct. UE was right here. Yeah, UC. All right. tension in CD. I'm going to identify both ends here. Tension E, which is DE, and then tension in F. But he told me it's 20 kilograms, so I can just go in here, 20 kilograms times 9.81, and this has got to be equal to 0. So what is produced here? This is simply sum of the forces, and this is equal to 0. If you multiply this one out, and I challenge you to multiply all of that out, that will give you the sum of the forces as an equation. So what I'm going to do now is I'm going to take this, multiply that, move it to the other side. What you're going to see, minus 1, cosine 30, 0, sine of 30, TCD. Now, this is very unorthodox. And take this, multiply times that, move it to the other side, becomes 20, 9.81, and 0. Okay, let's go in here. Yeah, okay. So now I want to clear everything out, CLC, and then what I want to do is I want to make the K matrix equal to minus 1 cosine degree of 30. Then the next row is 0 sine degree of 30. That gives you your matrix. You take the inverse of your K, you multiply it times a matrix which has 0 on the first one and 20 times 9.81 on the second one. And this is your tensions in newtons. And already I've got a problem. My problem is I goofed and my finger hit the 0 key instead of the negative key. Okay, that should be K. That should be, okay, 339. Okay. And 392. If you want to take a stop, we can look. Okay, this is 329. Now, okay, we'll do it this way. I don't want to have to keep bouncing back and forth. Let me make sure I line these up again. Oh, shoot. Okay, wait a minute. Yeah. Okay. Now, I have listed them one way. They've kind of listed them different. DE, I listed mine as tensions. DE, he listed his as F. I think we're okay there. CD, my tension is that. I'm guessing that maybe, okay, it's that 0.8. He's rounding. So now what do you do to complete out the next phase, which the next phase is looking at this ring? Well, it's not that difficult. You've got that. You've got this one. And you've got this one. Now, what we could do is sort of work down a little bit here. So this would be, we'll call it UD, base vector, unit vector, unit vector, unit vector in the A direction, unit vector in the B direction. I'm going to go ahead and just list the matrix out. Again, this is really unorthodox. UA, UB, UD. Put a divider between all this. Okay. This is going to be the tension in A, tension in B, tension in D. Turns out the tension in D is common to both of those. CD, and that's the 339, or in his case he said 340. So you take that out, you put in 340. Now what do I have? UA. Let's start looking at the UA vector. The x component is 3/5. The y component is going to the left, going up it's 4/5. The b going to the left, it's 45 degrees. Left, 1 over square root of 2, y 1 over square root of 2, because the vector goes like this. If this is length 1, this has got to be length 1 over square root of 2, 1 over square root of 2. Why? Because that's 45. That's 45. Check it yourself. Cosine of 45 equals sine of 45 equal 1 over square root of 2. I'm going to the left and I'm going down. UD, what does it go? Straight to the right. Oops, I said straight to the right. Put a nothing there. Okay, now, so my matrix itself ends up being minus 3/5 minus 1 over square root of 2 minus 1 over square root of 2 and 4/5. I have a tension in A, tension in B, and took that 340, did it here, moved it to the right side, became 340. Let's see what we get here. Okay, K equals to minus 3 divided by 5 minus 1 over square root of 2. Next row, 4/5 minus 1 divided by square root of 2. I get a matrix which looks like that. I can take the inverse of that matrix, multiply it times a vector, which has minus 340 and 0. And I get 242. I'll have to just write that down. Okay. TA 242, or 2, okay. 243. And TB 275. And 275 and the 243, and we're good. Now, this is quite unorthodox in the way this happens, but if you are comfortable with matrices, this always works. It just does. So That's pretty much it. Um, so I'm going to call it good, and this thing will be out there as a recording, and we'll go from here.